Hello everyone, Saurabh this side, and I am from IMTech IT 5th semester IIPS DAV, and this project is guided by Shalikram Prajapati sir. So in this video, I am going to discuss the internal test 1 and 2 which were taken by sir, and I will also explain their solutions. So let's start the video. So first, seeing the first question, the question that came in first internal was that we have to find the splitting criteria for these tuples using computation of information gain, Gini index, and then we have to compare both of these cases. So let's find out what is given here. So this following table present a training set D of class labeled tuples randomly selected from all electronic customer database. The class label attribute by computer has two distinct values. Here we can see that Bice computer has no NES. Therefore, there are two distinct classes, that is M is equals to 2. Now, if class C1 responded to yes and class C2 responded to no, there are 9 tuple of classes. Okay. And if there are 9 tuple of classes and yes and 5 tuples of classes number A node N can be created for the tuples in D. So basically we have to find out the splitting criteria. So let's see the solution and try to understand the question. So here, this is the given table which has following attributes like RID, age, income, student, credit rating, and bias computer was the main class. Now the root was credit rating, as we can see here, credit rating, and then excellent, fair, yes, no, or age or income. First, information gain. So firstly, we have to find out with the help of information gain. So we will find out the entropy of the root node. So P1, yes. For yes, it will come out to be 9 by 14. P2 for no, it will be coming to be 5 by 14. Now the information gain, now the entropy will be minus P upon P plus N log log power log of P upon P plus N and minus same P upon P plus N log P upon P plus N upon P plus N. Now with the help of this entropy formula we will get the answer which is nearly equal to 0.940. Now here we will calculate the entropy and information gains for each and every attributes. So this table shows the final information gains for every attributes like age, income, student, credit, rating. Now here we will see that what is the highest information gain. So here we can see that 0.324, that is for credit rating. So credit rating will be the root node in our decision tree. Now, similarly, we will find out this through Gini index. And for Gini index, the formula is 1 minus probability of yes into the into Gini. Here we will find out the Gini index for the root node that will be coming out to be 0.459. Then we will calculate the Gini index for each attribute. So after calculating the table, we will found that the Gini index will be in this categories, and the Gini index with highest value will be the root node. So sorry, smallest in Gini index will be the root node. So here's 0.278, which is for credit rating. So the credit rating will be the root node for the decision tree, as we have seen earlier too with the help of information gain. Now, decision trees and rule comparisons. So decision tree using information gain will be looking like this. That is, credit rating will be root only, and then excellent and fair. For excellent, there will be yes, no. for fair, age, and subparts. Now rules. If credit rating is excellent, then buy computer. That is, if credit rating is excellent, then yes. And if credit rating is fair, then consider age. And if it is fair, then you have to calculate the consider age factor too. And the credit and the decision tree using Gini index will be like this, where root node will be also credit rating only, and excellent and fair will also be there. But here you can see a slightly change that after fair it will be towards income. That is, if credit rating is excellent, then buy computer. That is yes. But if credit rating is fair, then you have to consider income. In information gain, we have to be considering the age, but here we have to consider the income. Now let's see the comparison. Both trees start with the credit rating as the splitting criteria, yeah, and the information gain trees then consider age, and while gain index trees consider the income. This difference could lead to different outcomes for specific cases, and the choices of matrices, that is information gain or gain index, can influence the structure of the tree or the rules. Like if we are taking Gini index, then we can have some different structure of trees, and for information gain, there can be different structure of trees. So we have discussed the comparison between both Gini index and information gain. So let's move ahead and start with the second paper. That was the first question is write an algorithm for decision tree induction. So the first question can be solved like write algorithm for decision tree induction. So first, we have to find out what is a decision tree induction. So, decision tree is a supervised learning method used in the data mining for classification and regression methods. It is a tree that helps us in decision making purposes. The decision trees creates classification or regression models as a tree structure. These classification and regression models are used for supervised and unsupervised learnings in data science, and decision trees creates important rule in following regressions and classification. Now let's see the algorithm. So the first step can be begin the tree with the root node and say S, which contains the complete data set. Then the step 2 will be find the best attribute in the data set using the attribute selection measure. Then divide the set into 5 subsets that contain possible values for the best attributes. Then step 4 will be generate the decision tree node which contain the best attribute, and at last recursively make new decision trees using the subset of dataset created in step 3, and then continue this process until a stage is reached where you cannot further classify the nodes, and that is called the final node or a leaf node. That is the answer for that decision. So the decisions trees use multiple algorithms to decide to split a node into two or more subnodes. The algorithm selection is also based on type of target variables. For example, some algorithms are like ID3 algorithm, C4.5, CART, and Mars, and etc. Now let's go into the second question, that is, what is attribute selection measures? Explain three of them. So, attribute selection measure, also known as feature selection criteria or split criteria, and are used in decision tree algorithms to determine the best attribute to select at the data at each node. First method can be random selection. It is not a, but it has some disadvantage, like it is not a good method and it can lead to inaccuracy and give wrong result as random values or selections are given. Second method is using information gain. It is based on the concept of entropy, and first we will calculate entropy and then information gain is the reduction in entropy or gaining information by selecting particular entropy for the splitting. And the node with the lowest entropy and more information gain is the splitting attribute, that is the node attribute. Now the third method is using Gini index. Gini index is the method of impurity, and it represents the probability of incorrectly classifying an instance in a dataset. A lower gain index indicates a purer dataset. So lower impurity indicates the node or the splitting attribute. Now let's move toward the third question. Define and write mathematical expression of information gain index and reduction in impurity. Now, information gain. So information gain is measured used to decide the order in which attributes are tested in a decision tree. It quantifies how well a particular attribute separates the data into classes. And mathematical expressions are like this: E is equals to minus sigma I 1 to n. Pi is the probability into log base 2 Pi, that is entropy. And gain SA is like this. Going towards gain index. So gain index is another metric used for evaluating splits in a decision tree. It measures the impurity or disorder of a set of data points. Mathematical expression for gain index is like this. And third one is reduction in impurity. Now definition is that in the context of decision trees, the reduction in impurity measure how much the impurity decreases after a particular split. It is used to assess the effectiveness of a split. The common impurity measures include Gini impurity, entropy, and classification error. Now, coming toward the last question, explain concept of overfitting and pre-pruning. Now, overfitting is a common problem that needs to be handled while training a decision tree model. Overfitting occurs when a model fits too closely to the training data and may become less accurate when encountering new data or predicting future outcomes. And in an overfit condition, a model memorizes the noise of the training data and fails to capture essential patterns. The key, let's find out the key characteristics of overfitting. They include higher training accuracy and low test accuracy, complex models, memorization, etc. Now coming towards tree pruning. So it is a technique used in decision tree algorithms, including those for declassification and regression. Decision tree have a tendency to grow excessively deep, capturing the noise in the training data and leading to overfitting. So pruning is process of removing the parts of the tree that do not provide significant predictive power, thus simplifying the model and improving its ability to generalize. For example, here we can see this is a decision tree with unpruned, which is unpruned. Therefore, here some extra or the nodes which are not required are also given, which make it complex. But after pruning, it is looking like this, which is a shorter and much easier to be evaluated and improved to understand. There are two main types of pruning: pre-pruning, post-pruning. And tree pruning helps prevent the overfitting in decision tree models and ensure that the tree captures the essential patterns in the data without memorizing the noise. So basically pruning makes a decision tree get rid of the unnecessary noise and make the decision tree much more precise and shorter to be analyzed. Thank you for watching.